Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right, welcome to Happy Path Programming. It's a beautiful snowy day here in Crested Butte. We have a wonderful guest back on, Paul Snively, who's always a pleasure to learn from. And we had you on 4.5 years ago. But before we dive into that, Winter Tech Forum is coming up, and it's the first week of March here in Crested Butte.
It is, yeah. Looks like there's going to be a nice turnout, and
Nice.
we're gonna, as usual, do some new experiments. Small tweaks, testing out new ideas, and we have a bunch. We have 10 students and 2 professors who are coming from the university down the street, and then a lot of the folks who usually show up, a few new folks, all
Nice.
that. So
It's going to be great.
wintertechforum.com. You can sign up now and consider it. It's it's an adventure because you come up to Crested Butte. There's all that stuff. And
Skiing and fat biking if you want, and
there's all kinds
ice skating and snowmobiles, and it's just something for everyone.
There's all kinds of things to do, and we everybody seems to always have a super good time. So it's unique among conferences, I think we can safely say. Yeah. So
good. Well, I hope to see you all here.
Mm-hmm.
Paul, so we had you on 4.5 years ago, and the title of the episode was what? The Future of Everything or something?
Little ambitious. Yeah.
Little ambitious.
No pressure.
Yeah. And you've on social media, in many conversations referenced that episode and said, like, my thoughts have been on this topic have been stated in this episode. And so thank you for continually pointing people to that.
Absolutely.
I think we covered a lot of ground.
We did. You guys were very patient and generous with your time.
Yeah. And you said you re-listened to that episode, which I should have done, but did we get anything right? Like, did we, in that episode, we talked about the future of software development, and AI wasn't even on the scene then. Like,
that's right.
The world's changed a little bit.
So one way to look at that is there's a miss, right? I mean, if you just want to look at it at the 50,000 foot level, but there were 2 things that we touched on then that have definitely evolved, and so if you want to look back at those, one came out of a question that you asked, and I think it was in response, if I remember correctly, to something I was saying about the work that Tim Sweeney has done and is doing with respect to designing languages, which is something that I think a lot of people might not expect from the CEO of a game company, right? And at the time I said, he's got to reduce support costs because he has all these sub-licensees, including sub-licensees like Microsoft and Sony, who have their licensees, right? So we're talking about tens, if not hundreds of thousands of developers that are using the Unreal technology, the Unreal Engine in one form or another. And I remember saying he invented a dependently typed programming language that never saw the light of day called Lambda Aleph. And I think the reason for that, this is just my opinion, I think the reason for that is just he's keenly aware of how if he releases the wrong thing, he's going to be swamped by support costs. He can't ship something that is hard to use.
Yeah.
And now
so he's had to balance the middle ground of where many developers are with the ideals of what would sure be nice in a language.
Right. And now here we are 4.5 years later.
When you're in a situation like that.
Very. But, Tim guards his time jealously, I would say. And so he's been successful in running those experiments to the point where Epic now has a new programming language, which has a beta version of it has been in tens or hundreds of thousands of users' hands in the Unreal editor for Fortnite called Verse. And the version that's in the Unreal editor for Fortnite is called Betaverse. It's not the full language. But if you look at all the published materials and presentations and so forth on it, looking back at our conversation 4.5 years ago, I said, wouldn't it be funny if the future of easy to use programming was some dependently typed programming language. And here comes verse. So the full version of the language is not available yet. They are going to release a reference implementation when it's ready. They have the luxury of deciding when it's ready. It's not out yet. But, they also have the power. They hired Simon Peyton-Jones away from Microsoft Research to work on this, and Leonard Augustson and Owen Shivers, and I think am I remembering his name correctly? Anyway, there's this big who's who of people working on this project and have been for several years.
So there's maybe a common assumption that a dependently typed language would be far too complex or complicated, I don't know which one, for the masses to use. And we're talking about, not, we're talking about like my kids want to build a Fortnite, plugin or whatever.
Yeah,
and
absolutely.
Like, could my 8-year-old son understand a dependently typed language? And that seems impossible. But what I think what you're saying is that they maybe figured it out.
Yeah. And can you even call verse a dependently typed language in the sense that Idris is, or Agda is, or what are some of the others? F star, and on one hand, there's a sense in which the answer is yes, and there's another sense in which the answer is no, because verse's type system is not at all conventional. To the extent it even has a type system, and there you go. So if I may toot my own horn, I did a presentation on verse at LambdaConf this year. So
I'll have to watch that.
Yeah, check that out.
We'll fit that in the show notes.
When you're really, really bored and have an hour and a half to spare. Actually an hour, 50 minutes, I think. But anyway, so looking back at our last conversation, I think there's at least one shot coming at the idea of some of the really high-end power that we can get in certain classes of programming languages becoming available in the mainstream. And it's hard to imagine something more mainstream than the programming language that supports the Unreal Engine. That's literally as mainstream as it gets. Here we are. People are writing verse code today. It's just not with the full. It's a logic functional language, and that's another thing that your question last time, James, in particular, was, boy, what's going on with declarative programming? That was one of the questions that you asked.
Diving into that.
And so here we are. We're talking about a logic functional language. So we're talking about a language whose closest relatives are Mercury and Curry.
Yeah. So I think there was some, last when we talked, there was some hope that the things that we believe are better ways to program would propagate to the masses. And so I think the recap of the update here is that, yes, it's happening, and verse is one place where we're seeing this happen, that some of these approaches to how we can get to better software reaching the mainstream is happening. And the effect TypeScript library has, I think, been another case of that, where effects are going much more mainstream through that avenue than they kind of ever did with Scala and their languages that support effects.
Or anywhere else, right? Yeah, for sure. And I think that's an interesting trajectory, and I'm glad you brought it up, because we can even talk about who the connective tissue is there, right? Some people might not know the history, but Effect.ts is literally a port of Zio from Scala to TypeScript. And when we talked last time, I remember saying, and I watched it again, or I should say listened again yesterday, I talked quite a bit about how I was skeptical of Zio because it eschewed hierarchy types and type classes, and these things that Scala really has, in my opinion, certainly to offer by way of writing those kinds of libraries. And then here comes Effect.ts. TypeScript doesn't have higher kind of types. TypeScript has no more native type class support than Scala did. So you have to encode these things. And it makes more sense to me because, my question to John DeGoes historically was, why would you avoid these features in Scala that are, quite powerful? Granted, they cause certain kinds of challenges. And okay, so if you're trying to appeal to newcomers, maybe that's a good enough reason. Well, then you take that rationale and you bring it to TypeScript, and it's like, okay, this makes perfect sense. to me. And so, yes, here you are. The message that was always part of Zio, from a marketing perspective, at least, it has proven itself very, very effectively with effect in TypeScript. People are falling all over themselves to use effect in TypeScript. People who never, ever, ever, ever would have considered using a Cats or a Cats effect or a Haskell or whatever.
And people not even coming from a functional programming background.
Right. That's why I say, don't tell. Yeah.
Exactly. Like we've somehow tricked people into doing functional programming.
Right. But I think that's how it's going to go. And the same thing applies to verse. One of the points I make in my presentation on verse, not to keep making the commercial about that, is that part of its selling point is the syntax is derived from C# and ECMAScript.
Huh.
It is. So it's bog standard almost in terms of its mouth feel.
I think that's really important. Like I really like a lot of the ideas in Unison and in Rock, but the fact that they chose the Haskell-y like syntax, not the what's the foundation of the languages
Algol.
I just like that syntax more, and I'm sure it's just that's what I'm familiar with.
Well, and I think we go, oh, it's just because you're familiar with it, and yet that's a bigger factor clearly than we want to admit.
That's the place I've very uncomfortably landed over the last couple of years. In particular, its syntax is not only important; it's very nearly dispositive.
Sorry, what? Dispositive?
Yes. Sorry, legal term.
What does that mean?
I don't know this word.
So the root is dispose, right? So you can dispose of an argument. So dispositive is, closes the book on the conversation, basically.
Okay.
Yeah.
The syntax,
could be worse. Like, syntax is dispositive. Yeah. Almost.
Yeah, I mean, generally most new languages that are coming out are using Algol syntax, and so it becomes like this reinforcement loop where that increases familiarity, which then causes more new languages to make that decision, and so
and then your question for people like us who are interested in weird languages is: does familiarity breed contempt? Have we now spent decades looking down our noses at these languages with these sort of not very interesting syntaxes, and it's like, well, should the syntax be the most interesting thing?
Yeah, should the syntax be interesting at all?
Right.
Because then you're running into
right. And so we have the newbie onboarding problem. Not to be pejorative in saying newbie, I don't mean to make that a value judgment. So how do you appeal to people who are new to programming and give them the leverage that you want everyone to have? And I think those of us who are interested in exotic languages are sincere in our desire to give other developers the power that we appreciate about these weird languages, right? And certainly that's why I talk about them in public. Otherwise, I wouldn't, I can't think of another reason why I would do it. Other than, I suppose, self-aggrandizement, and I hope I'm not that guy. But I do think we've worn the hair shirt, and here I'm ripping off Simon Peyton Jones again, as usual. But we've worn the hair shirt of, oh, this syntax is weird. And the payoff is you get these really interesting and useful and fun semantics, on the other side.
But does the syntax have to be weird to give you that payoff?
Right. And Verse's answer to that question is absolutely not. And that's why it's interesting to me. It's like, okay, this deeply challenges some assumptions that I had made for decades about that relationship, about the relationship between syntax and semantics. And it's like, oh, holy cow! If this succeeds at all, it will change everything. It really will.
Yeah. I really like that concept of leverage, and it's not something that I'd really thought about before, but the idea that what we're doing as programmers is we're able to leverage technology to accomplish things, and there are different technologies that give us more leverage than others, and maybe the stronger, the more capable of programming languages is potentially giving us more leverage. And I really like that idea. And AI is certainly giving us, even more leverage. But ultimately, like, it's like how much work do we have to do to accomplish a given goal? And that is what the leverage is, right? Is there other pieces to that?
Yeah, probably. We're not there yet, in my experience with AI, but we're, it's right now. It's the California gold rush all over again. The people making money are selling picks and pans and shovels, right?
Yeah.
And that's as it has to be at this stage, where that's where your innovation budget has to go. At this stage, right? It's still early days. Here's a funny story that just happened very recently. So I've been experimenting with local models, like I think most developers have, and I have an RTX 4060 in this laptop.
Nice.
So, yep, it's not a bad chip. It's 8.9 compute power when you ask about CUDA compute power. And if you Google that, it's like, oh, very good. It talks about how great that
crunch a lot of math
is
on that thing.
You can crunch a lot of, you can do a lot of linear algebra with that kind of compute. But with 8 gig of VRAM, it's all about the memory bus bandwidth and access to those
you can't load
tensors.
A very large model into that.
Not at all.
Space. Yeah.
and so now it gets interesting, because now we have to talk about dense versus sparse MOE models and all that kind of stuff. And we can talk about that in a minute. But the story I want to tell is here's how fast moving things are. The proprietary NVIDIA driver for Linux does not support a unified memory architecture, but their open source Linux driver does.
Bizarre.
So I installed the open source NVIDIA driver on my Linux box here. And there's a tool called NVTop, by analogy to HTOP, right? And it shows you all this nice information about, where your GPU, your level of GPU consumption and your level of GPU memory consumption and all that kind of stuff. And it lied to me. At one point, I disabled the unified memory architecture, but was still using this driver. And I pulled up NVTop, and it was like, hey, you've got 16 gigabytes of VRAM. And I'm like, no, I don't. I've got an RTX 4060. You are lying to me. And then I did some Googling and come to find out that this was a known bug in NVTop. And they fixed that bug in NVTop, and the release with that bug fix happened Tuesday of this week.
Okay. So you just happened to encounter this odd bug, and that's fascinating that in something kind of low level, obscure, if there's enough users, we can figure it out and find it and figure it out and get it fixed.
That's the good news. That's the positive side of it, right? That all this is hopefully converging very rapidly. But then, again, where do we put our innovation budget? So if you're playing with local models, a few things, right? There's LM Studio, there's Llama CPP that you can run on its own. There's VLLM. There's a Llama. So first of all, you have a number of possible runtime environments. You have a number of possible tools that you can use to run these models. And then there are the models themselves, right? And if you go on Hugging Face, there are thousands and thousands and thousands of them. And if you try to narrow that,
millions of models now on Hugging Face? Like
I have absolutely no idea. Right?
I think it's in the millions.
It probably is.
Wild.
But even if you just go with the obvious 10 or 12 that people talk about, it's still 10 or 12.
Yeah.
that people talk about.
Yeah.
And
Quinn,
then,
DeepSeek, and
yep, yeah, and
Olama,
Mistral
Mistral.
and Nematron. So, and when you look at these and try to use them in one of these runtimes, you find out a couple of things. First of all, the engines and the models are tightly coupled. If you look at the change list for llama.cpp, which by the way is the backend for LM Studio too, so it's it's kind of omnipresent almost. If you look at the change list for llama.cpp, there were 5 tagged releases on GitHub yesterday. 5 tagged releases. Why? Because GLM 4.7 Flash dropped. So they had to revise Llama CPP to support GLM 4.7 Flash.
That's a
Why?
tight coupling. Yeah.
Right. And then there's, right. And then you look at Unsloth's models on Hugging Face, and it constantly says, we fixed the chat template on this model. And it's like, what do you mean you fixed the chat template? Well, it turns out that these engines implement some template engine, typically Jinja, Jinja 2. So this is all about Python, first of all, which is its own sort of special snowflake of a problem. So you can have a model that the engine you're running the model with has to change in order to support, and separately or in conjunction, you can have the chat template associated with that model not work with a particular engine. And it could even be whether it works in LM Studio and not in Llama CPP like Llama Server, or vice versa, even though LM Studio uses Llama CPP for its engine.
Wow.
It
seems like some of our foundations here are a complete mess.
Mira Sorvino stars in this film. Sorry, that's a Mimic reference. If you're not
Don't
familiar,
know that reference.
Yeah, Guillermo del Toro. You have to go watch Mimic. Watch the director's cut of Mimic. It's it's Guillermo del Toro and Mira Sorvino and Jeremy Northam, and I mean, go watch. But anyway, it's this hodgepodge of things that have to talk to each other, but it's all predicated on the non-determinism of the model. Right. So even when you say, well, gosh, how hard can it be to parse a tool call? Well, ask the model, because it's the model doing the parsing.
Yeah.
So you don't have this nice, it's like, of course you use this JSON parser. Of course you use this XML parser. No, the model is actually parsing this structured text and is supposed to make sense of it.
Instead of a deterministic function call, it's actually just said, okay, this token sends me on this path, and wild that all that stuff is just all encoded in this model.
Yeah, we shovel these XML tags or these JSON brackets or whatever to the model, and then we hope that we get a valid piece of JSON or XML back, and maybe for the big frontier models online, that works, that seems to work pretty well, right? It seems to work pretty well if you're
very tuned to be able to manage that.
It's like, yes, we can, we do this pretty reliably. You might not even know that this sort of interaction is going on, right? You might know that there's a thinking model versus an instruct model. You might not know what that means, right? But you know that there are those two broad classes of models.
Is putting all this stuff in the model the only
right way?
Or like, is there a better, can we get to a better solution here that would be more deterministic?
I mean, obviously, given my priors, right, given my prejudices, I think you know what the answer to that from me is going to be. And I'm not the only one. There are people who are doing things like, including even bigger question kind of things, like how do you validate? It's like, what does it even mean to validate the result of you're talking to a large language model? So there are people whose research involves integrating large language models with theorem provers like Lean. That seems to be a kind of a hot topic in certain circles right at the moment. So I do think there's an opportunity to have this kind of check your work, kind of cross correlation kind of exercise between what you get out of a neural network and what you get out of a theorem prover.
Yeah.
And this is particularly interesting if you have any interest in algebraic information theory and information theory generally, I suppose, but particularly
What is the
algorithmic rather.
how is it? Yeah, I think it is. My question is along those lines: is in the world of like math and algebra, how do we reconcile models, or how do we connect models with functions or operations?
Yeah, right. Yeah, and I think we have to think harder about how to formalize the investigative process in mathematics and logic, and I think that we sort of nodded at this through the 2010s and into the 2020s a little bit by observing that deductive logic is almost nobody actually does deductive logic. It's almost a commonplace in certain circles. It's like there are entire books that have been written about if you read Sherlock Holmes absolutely never uses deductive reasoning. He uses abductive reasoning, or inductive reasoning, or both. And it's like, okay, yes. And then I'm looking over at my bookshelf right now, and I've got How to Solve It, Polya. And How to Solve It is literally a mathematician's look at how you come up with something that you could possibly prove in the first place. And it's not deductive. It's very much inductive. And so I think there is room on the inductive abductive reasoning side of what we call math and logic to say, yeah, there is, I think, a role for LLMs here. There's certainly a role for non-determinism here. I mean, How to Solve It is very much about you proceed down a path, you run into a roadblock, you backtrack, and then you try something else. And it's like, okay, there's your non-determinism. That's the kind of thing that Prolog does. That's the kind of thing that logic programming does. And so how, could we lift and shift Prolog and replace that with another approach to non-determinism, which might be one of these large language models or what have you.
Yeah. Fascinating. One question I had for you, we got together last night and we're working on the new effect-oriented programming book for the TypeScript version. And at the end of the night, we got into this interesting, exploration of what seems like a dichotomy between eager evaluation and lazy evaluation. And it seems that, and you know way more about this than I do, so I'm curious your perspective, but it seems like a language can be either lazy or eager. And then effects create this like weird middle ground where portions of the program then become lazy. But I don't know. Tell me in this world, like
would it be more precise to say deferred rather than lazy?
Yeah, you could say deferred or deferred execution or
yeah.
But why do we seem to have this dichotomy in languages? Like, why do you seem to have to pick one side or the other?
Well, Bill might say that James got stuck in a local minima where he couldn't get himself out of it. And Bill's argument, that I went along with, was that the programmer has to make a decision on some of these things, and this is putting that decision in the programmer's lap. Do you want to return an effect that somebody else can then use to compose other effects, or do you want to get the result, get the answer, and turn? And that's anyway. What?
Yeah, and follow up to that is that if something is deferred, then that requires the caller to cause the evaluation of that to happen. Like you've put the decision of evaluation on the caller side, and I don't know, like what's the reason why we have this two different approaches, and why do different languages choose one or the other? And then are effects the right middle ground that helps you bridge the gap between these two worlds?
Yeah. Well, the short answer is that effects are the reason. So if you go all the way back to the 1930s and you look at the Turing machine and the lambda calculus and all this kind of stuff, the lambda calculus is interesting because I forget exactly what's the best way to frame this. Um, in the it, in the presence of referential transparency, there's no observable difference between eager and lazy evaluation. And that's one of the mathematically interesting things about the lambda calculus. Then you fast forward to, I think, Algol 60, and there were some aspects of Algol 60, or maybe just the entirety of Algol 60. I haven't actually used Algol 60. I'm just familiar with the history. But there was something about Algol 60 that at least presented the opportunity for laziness and introduced, obviously, effects like I/O, right? And all of a sudden, users of Algol 60 were bumping into, oh my gosh, this I/O is happening at the wrong time. It's, it's happening unexpectedly. It's like, I thought it was going to happen here, but because this call didn't actually get evaluated until such and such time, it happened, some other time, some other place. And I think
this was their call by reference, right?
Yeah, something like that. Again, I'm not familiar with the specifics, or at least I can't recall the specifics.
Or
but
call
Algol
by name,
60,
I think is what it was. Call by name, yeah.
Yeah, call by name, yeah.
It's
versus call by
basically a
value.
thunk.
Right. So, yeah, and that was the terminology at the time, call by value, call by name, and in fact, I suppose still is. Haskell is interesting because it's call by need, which is call by name and memoization. So nothing gets evaluated immediately, not called by value, but it gets called the first time, and then whatever result it returns, it memoizes, and then if you call it again, it just retrieves that value that it got last time. So that's already a compromise, right? A certain kind of compromise. How do you know that you want that value memoized after making that call? Is that always the right thing to do?
And the reason, back to what you stated at the beginning of this, was that they do that for referential transparency.
Referential
right?
transparency. Yeah. So if you want a consistent view of the world broadly construed, the totality of your program, then you have to make one of these choices. And there are other pragmatic aspects to it too that we haven't even talked about, like the efficiency of call by name. And one of the reasons that they chose to memoize the result is because you probably don't want to make that call every time.
If it's referentially transparent, why recalculate the thing after you've done it once?
That too, yes. But then there comes the question of, well, what if you're calling something that has an effect that is responsible for that return value, but if you made that call again later, it wouldn't return that same return value. The obvious example here is clock. All right, everybody's favorite distributed system bugbear, right? Is the clock is an external aspect of your system. If you have an external clock, if you call the function to get the value from that external clock, it'll be different, of course. You hope, right? Otherwise, it's not a clock. And it's okay. What do you do with that? And it's like,
it's not referentially transparent.
Yeah, not at all. And so it's easy to come up with these kind of conundrums, right? And people did all the way back in the 1930s. And it's like, okay, what? And so it's like, okay, the lambda calculus is hopeless when it comes to actually dealing with effects, and until you get to Maggi 1991, blah blah blah, monads and all that kind of stuff. Now we're talking about algebraic effects, and we've come full circle. So to try to bring this home to your actual question, yes, we impose a version of laziness on otherwise eager languages like Scala, like TypeScript for that matter. When we thunkify, that's a simplistic view of how we embed effects or integrate effects, right? There's much more to effects than thunkifying something. You can't just wrap something in a lambda and say, do this later. There's much more to it than that, and that's what Maggi accomplished, was to figure out what the rest of that was. Um, I encourage everyone to read Magi 1991 who has any interest in effects at all, because it's where effects and lambda calculus came together.
Okay. I'll
yeah.
put that in the show notes, and I'm going to
Right,
add it to
right.
my list of,
Yeah,
of reading.
right. It's a great paper. It's dense. It's mathematical, so it might not be standalone, but certainly worth as a launching off point, if nothing else. I would
So,
say.
would there be any value in a lazily evaluated language if you could instead have a eagerly evaluated language with the concept of effects, like basically like Scott, like I'm wondering,
Yeah.
like, is the sweet spot, the optimal solution, eager evaluation with effects that are lazy?
Well, that's what we get, right? That's what we get with a Scala, with Zio, or Cats and Cats Effect. So we kind of have our cake and eat it too. Most of the language and most terms in the language are eagerly evaluated, and they reduce to normal form, and you're done. And that's great for efficiency, and that's really the big win of eager evaluation, right? Is just it happens once and for all, and if there are no effects in that term, then that's really what you want. And then we again,
it's like if I have no reason to be lazy, why be lazy, right?
Right. And I think that was, if you go back and look at the early languages like Algol 60, I think that was just the thinking, because of course, what was the alternative? The alternative was Fortran or Lisp, and both of them were eager as well. And again, not just because that was the obvious thing to do from the machine model perspective that everybody sort of had in mind back in those days, naturally, right? But also because, again, how to efficiently evaluate lazy lambda calculi is not obvious. There are, one of the major breakthroughs of Haskell actually is that it's an answer to the question how you efficiently evaluate a lazy lambda calculus. And the foundational paper there is the spineless tagless G machine. So add that to your reading list.
Okay. But they figured out, like, okay, given that everything's lazy and there's inefficiencies to that, how do we overcome those inefficiencies? And they found a way.
Yeah, you've got a lazy lambda calculus, and you've got an aggressively pretend von Neumann architecture, and as a target, and I'll come back to that later. But that was the subject of at least one thesis, which was Leonard Augustin's thesis. And then again, Leonard now works on verse at
Okay.
Incidentally, you guys are going to get so sick and tired of me talking about this. Verse is leniently evaluated.
What does that mean? Evaluated? Oh, wow. Okay. Unravel that one for a moment.
Yeah, I would love to, but it's so badly documented. If you do a literature search for lenient evaluation, there's like one language ever that has been leniently evaluated called ID 90. And the only reason I know about it is because I learned about it from Tim Sweeney. So, it's like, but and I don't know if Tim would appreciate me making this observation, but it happens to be true. Epic Games is privately held, partially so Tim can engage in 20-year research projects without the pressure of the quarterly.
Sounds like he's got it figured out.
Yeah. So, he's been talking about what he's up to in language design for all 20 of those years. And that's most and more. And that's mostly what I talk about in my presentation. I'm not a Fortnite developer. I don't actually use Windows or PC. So all I could really do is kind of read the publicly available information and say, okay, here are some of the historical influences on verse, So if you watch my presentation, you'll probably learn more about Curry than you will about verse.
Which one's Curry?
Curry is a logic functional language that is very closely related to Haskell. and shares some of the limitations of that, like the syntax. But yeah, if so there are two major logic functional languages, Mercury and Curry. Mercury is what you get when you take a Prolog programmer and they want to invent a functional programming language. Curry is what you get when you take a Haskell programmer and want to invent a logic language.
Huh.
I mean, that's really how that breaks down. If you look at these, look at programs in these two languages, it's like, oh, this is clearly derived from Prolog, and this is clearly derived from Haskell.
And our logic functional languages all use lenient evaluation?
No.
Okay, so that was a unique thing about verse.
I know of only one, and now two, id90 and verse. Those are and so lenient evaluation. To oversimplify dramatically, which is all I can do because I have not used id90 or full verse doesn't even exist yet. But imagine being able to reorder assignments and have that work. Not run into the issue of you're trying to assign to a variable that hasn't been declared yet.
Yeah.
And that's just the simplest possible example, but it's one that Tim himself used in his 2006 Popl presentation, which I think I mentioned that before. If not, I should have. Look at the slides from his 2006 Popl presentation, The Next Mainstream Programming Language, A Game Developer's Perspective. And that's 2006. So now here we are. It's 20 literally 20
years later.
And there in 2006 is the Verse project laid out, like what are the goals? And now it's like, yeah, we're getting there. We haven't released the full language yet. Not time yet, but it's coming.
Is the to be able to make dependent types approachable by mainstream developers, did getting there require a logic functional language or lenient evaluation, or
I think so. Yeah. I think if you of course, as always, I'm going to leave you with a list of people you should talk to instead of me. So one of those would be Simon Peyton-Jones. So Tim convinced Simon that logic functional programming is the path forward. And so if you can convince Simon Peyton-Jones of that, I think there must be something pretty compelling about the argument, let's say, right? Yeah. So Simon Peyton-Jones and Leonard Augustin. So two of the major figures in the GHC and Haskell compiler world, right, are working on Verse at Epic. I think so that they must be persuaded, right? They must be convinced. Yeah. And so not to argue from authority indirectly. So then the question becomes, well, what do you want a mainstream programming language to be like? And we already touched on the question of syntax. The other major thing about Verse that I think is really, really important and compelling is that it supports pervasive software transactional memory. So you have actual no joke side effects. You have no joke assignment. You have no joke IO. You have all of this stuff, and you can only do those things in the body of a transaction, and then you either commit the transaction or the transaction fails. And so there's this very strong notion of success and failure at the semantic level. And when
we're on allocations,
right. All of
the side effect of an allocation.
The side effect of an allocation. Yeah. Remember, this language is intended to support soft real-time systems like games. Yeah. So this is not.
It's not a borrow checker.
Yeah, it's not. It's considerably more powerful than the borrow checker, and there's like a one of those kind of, oh my gosh, kinds of observations right off the bat, and it basically enforces internal consistency as aggressively as any language I've ever seen, while at the same time just visual, from a reading perspective, just kind of being like, yeah, you can do this thing speculatively. You can do all these things speculatively, and that includes concurrency. So you can fork off a bunch of concurrent processes, each of which is trying to achieve something. And then one of them can succeed and all the others can fail. And when the others fail, they roll back whatever changes they made.
Huh.
So it's like your internal consistency story is very, very, very strong. And your ability to just say, oh, try this. If it works, great. If it doesn't work, that's fine too.
Yeah.
And it all hangs together.
Huh.
And that is something that Tim identified as the way forward a very long time ago. Yeah, decades ago.
I want to ask, one of the things we were maybe observing last night was the idea that there seemed to be a set of orthogonal principles or ideas in effect systems that were, like provisioning is separate from, help me out here.
Acting on the resource.
You describe you describe an effect, and then you execute the things that actually result in that effect. Yeah,
right. Well, and then error handling is kind of a separate, so. And we're trying to
come up with our list of what are the core orthogonal aspects to effects. The dependency one seemed critical because one of the, I think, a realization that I had, and I think we talked about this last time, but is that an effect requires a system that it's going to act on, and there is no effect that doesn't have something that it's acting on. And in Zio, we kind of hide the clock and the random, and we don't actually put that into the type signature because it's just so commonly done to access some of these common dependencies. But every effect, the reason why you are going to model something as an effect is because you're going to perform an action on some external thing, and specifying that thing is it seems to be a critical aspect to effects
and a challenge. One of the big challenges. And when we talk about algebraic effects, what are we talking about when we talk about algebraic effects? So one of the big things, certainly in Zio and in languages like Coca and some of the research that led to things like Zio, is the idea that you have an algebra per effect. And so you already mentioned you have the clock and you have some sort of, IO channels and things like that. And they're separate. Whereas, historically, of course, you've had the IO monad. You've had the one monad to rule them all. And even Haskellers point at IO and go, this is way too big. This carries way too much freight. For what it does. It would be really preferable to break this down somehow. And then the question becomes how. And so algebraic effects are one answer to that. So you have potentially this list of effects that you would like to have. And it's like, lists. Well, that's a fairly, straightforward data structure in computer science. And it's like, well, here's a challenge. This is a type level list.
Yeah.
And now all of a sudden we're in this crazy world of, H lists, heterogeneous lists where, you have these different types, but they form a list at the type level, and you want to be able to append to it, and you want to be able to prepend to it, and you want to be able to remove things from it. Not only do you want to be able to remove things from it, you want to be able to remove them from the middle. At the type level.
And deduplicate, like an IO and an IO is just an IO.
Right. Yeah, exactly. Very simple and, in fact, simplistic. With the algebraic effect systems, including, I would say, Zio and effect TS, you literally have this business of, here are the capabilities, let's call them, as a type level list that go into this function. Here are the things that we want to be able to operate on. But then when we have operated it on that thing, we want the result type to exclude that type, again, possibly from the middle of this type level list. And Zio did that, and Effect TS does that. And that's a remarkable, and making that efficient, oh my gosh. And let's be honest, even with as much energy has been put into efficiency in these things, people still complain about compile times. With these, because you're now asking the compiler, you are actually asking the compiler to do a form of logic programming in the type system. And you're asking it to draw inferences on. Basically, you've got this. You've got both higher order sum and product types. So you have,
and
type
it's having to do a large tree resolution across those,
right?
Which gets pretty complex for the compiler to have to do that resolution.
So if you're familiar with lenses as a means of manipulating arbitrarily nested structure at the value level, with immutable data, right?
Yeah.
It's like you don't have the advantage of mutation in some contexts, so you use lenses. So you can imagine that these libraries that are doing this at the type level are basically using something like lenses to manipulate these potentially quite large, type structures and type level structures.
So it's tricky. I think. We were working on this code example last night that Bruce came up with, where we were just doing some pseudocode because we're trying to show like what is the essence of effects. What are we really trying to do here? Which I don't know if you want to give your I'd love to hear your thought on that. But then Bruce also is putting together
this is super easy. Yeah, this is so easy, but it involves an investment of time and possibly political upheaval. And that is compare and contrast, say, Zio2, the Zio type in Zio2, with the Cats Effect 3 type classes.
Yeah.
And if you look at the Cats Effect 3 documentation, I can't remember what page it's on right off the top of my head, but on one of their pages where they introduce the type classes, the Cats Effect 3 type classes, they explicitly say, here's what it means to be a functional effect. This is what we're trying to accomplish. We're trying to say what it means to be a functional effect. And of course, I think anybody's knee-jerk reaction to that would be, that's a pretty bold claim, right? Yeah. But then you consider that Cats Effect 3 runs on the JVM, Scala Native, and Scala JS. Yeah. So their claim holds up pretty well. It would have been one thing if it was like, well, okay, yes, you've implemented these type classes for the JVM. You've implemented these type classes for whatever reduced JVM alike you're using to build Scala Native. You implemented them for JavaScript. Well, they implemented them for all three. Yeah. So I think we have to say that the claim that this defines what it means to be a functional effect stands up pretty well. Nice. So, and then, again, take those things, take these individual type classes and what they do, and then do what Zio did, which is to say, if you wanted not to have type classes, if you wanted to combine all these into basically one type, the Zio type, what would that look like? And you already alluded to the answer to that, which is it takes an environment. It takes a set of capabilities that you can have in this particular box, this particular Zio box, right? Yeah. And then you take that and translate it to TypeScript, and you've got Effect TS.
Yeah.
So I think all of this has been very well validated. And I've told John that much, that he should feel immensely proud that Zio worked as well as it did by way of being adopted in TypeScript.
Yeah, and I guess that was working with the constraints of TypeScript, because TypeScript doesn't have type classes, so like Cats could not have been ported to TypeScript.
Does not have higher kind of types. Yeah. And in fact, there was another project in TypeScript Now I can't remember the name of it offhand, but it merged, joined forces with Effect TS. Oh, FPTS, of course.
Okay. Oh yeah,
FP,
I did look at that one at some point.
yeah.
So one of the
and
other aspects of effects that seem pretty critical is like encapsulated state,
Mhm.
like that you shouldn't leak state out.
Right. Right.
That one seems pretty obvious, and then that
Mhm.
allows for parallelism.
Mhm.
Assuming that your downstream system that you're interacting with is not going to have a problem with that, but from the effect side. And then another one that I think, going back actually to the deferred topic where we were on this thread last night,
Mhm.
was that it seems like there's some core aspect to effects that requires the thunk or the deferred evaluation of the actual thing.
Mhm.
Is that
Yep.
is that a
Fundamental.
requirement, a core
Yes.
aspect?
Yeah. I mean, the moment you point out that what you're doing is you're separating the description of the effect from the execution of the effect, you are talking about that in one form or another, right?
Yeah. And
So
all effect systems, whether it's algebraic or
yep.
monadic or whatever,
Yeah, right.
have that separation of
Have that separation.
Yeah.
And that's what's driven people nuts about the whole question of colored functions, right? What are you doing with that? You're indicating where, well, you're not actually doing a thing. You're returning a value. Right?
Yeah.
And I've said that explicitly in some of my presentations, that the name of the game here is to turn everything into a value. That was part of my keynote in 2018. To say the name of the game is to turn everything into a value. Values are values, failures are values, effects are values. They're all values. Why? So you can deal with them algebraically. And you do even deal with just your God monad. You deal with I/O algebraically according to the monad laws.
Yeah.
And it also has other type class instances like monad error. I think we talked about that last time. So monad error describes how I/O deals with errors and provides an algebra for that, as opposed to having the separate error channel as you do with ZO or Effect TS.
So the reason why we're making things values is one, referential transparency. Another is the algebra of the value, which allows for composition, and reasoning or soundness of these values as we
algebraic reasoning.
them.
Yeah, absolutely. The substitution model of evaluation. Yeah, we have all these phrases that those of us who are familiar with the history and the development and the personalities and the writing and all that kind of stuff toss around. The substitution model of evaluation. 1 + 1 = 2. We learned the substitution model of evaluation when we were in elementary school.
Yeah.
The thing that challenges programmers with the conventional approach to purely functional programming is that now we're talking about things like, oh, by the way, you can take this list of things that can have effects and you can do them all concurrently and you can assemble the results of all these calls and keep them in order. And you can reason that that's going to happen with the particular functions that you're using in your head with the substitution model of evaluation. And I'm here to tell you that that's a true statement because I do it myself. But I'm also here to tell you that I have sympathy for people who hear that and go, what the actual F are you talking about? It is not elementary school arithmetic. And let's be honest about that, right? If I have, and last time I talked about parfold map A, one of my favorite functions in the CATS ecosystem. Yeah. I called it Spark in a Box. But let's be honest, it combines the parallel type class, the applicative type class, foldable, hence fold map, right? Yeah. You're mapping over something. And it's wonderful, it's fantastic, it's unbelievably powerful, probably underutilized, in a lot of domains that I can think of when I'm writing some sort of back-end service.
Yeah. And real quick on that, on the CATS and the type classes there. Was there I feel like at some point there was an experiment, or maybe it's already there, where Katz was expressing the algebraic properties like commutativity through the type classes as well.
Actually, the Zio Prelude was the one that really focused on, here are these really basic building blocks that, again, you learned in elementary school: associativity, commutativity, distributivity, and how you can build a new functional programming ecosystem, I guess, around these really fundamental algebraic relationships. Among the simplest ones that I think we all know. And again, sort of looking back all the way to MapReduce and Hadoop and all that kind of stuff, right? What was the big insight there? The big insight there was that you can do distributed programming by forking off a whole bunch of independent processes that will complete at different times. You have no control over when these things are going to finish. And you can get those results back and you can reassemble them on the condition that the thing doing the assembly is associative. Right? Yeah. Parentheses A plus B, close parentheses, plus C had better equal A plus parentheses B plus C, close parentheses. Yeah. Otherwise, you're going to get different results depending upon what finishes first.
Yeah. Yeah.
Right?
So it required associativity as being as a core requirement. Unfortunately, that was not expressed through the type system in any way.
Right.
It was just,
not in Java. Right. Yeah. So there, but it was lore. It became lore. And I think associativity is, people might have to dig around the cobwebs in their head a little bit. And it's like, but you only have to spell it out like I just did once, right? Parentheses A plus B close parentheses plus C equals A plus parentheses B plus C close parentheses. That's associativity. Yeah. And everybody that hears that, whether they're a programmer or not, is going to go, oh yeah, right, of course.
So the reason why this matters with effects is that we want to have values, using modeling effects as values, is so that we can do these composition operations and have it abide by the algebras that we expect to work. Like,
have the effects happen when they're supposed to.
Yeah.
and not when they're not supposed to. So back to eager versus lazy evaluation. If you write your code and you say, print this thing to the console, and it prints that thing to the console as soon as that expression appears in your code, that effect is probably not going to happen at the right time. It's going to happen prematurely, right? And in particular, if you embed that in some context that is doing something concurrently and repetitively, then if it happens the first time and only the first time, that's wrong. If it happens out of order, whatever that means in a given context, with a set of things that are happening concurrently, that's also wrong. And that happens all the time. Like if you're writing a backend service that consumes 3, 4, 5 other backend services, has dependencies on those, and you have to do things concurrently, and those things that you're doing concurrently, to one degree or another, depend on the results of those services. You're making a REST call and you get a result, you get a JSON object back. Okay. And you need to do something with that JSON object. Multiply that out over 3, 4, 5 other backend services and express the dependencies among, it's like, okay, well, the input to this one depends on the output of that one. Oh, and these other over here are independent, but they serve as inputs to this over here. And, the next thing you know, it's like, and then again, you have the problem that these can complete at different times. These results can come back at different times. You have to coordinate all this stuff. Yeah. And James, why am I telling you this? You have the best test bed for structured concurrency I've seen in my entire life.
Yeah, easy racer. Thank you. Yeah, and thanks for your contribution of the Katz effects one.
Well, I got started. Somebody else took it over the finish line, but yeah, thank you.
Yeah, it continues to be a fun project that I've continued to evolve. The most recent one, with that total tangent, but side note, was I was having a really hard time with the JavaScript implementation, and this was just like standard JavaScript, and the underlying reason why the JavaScript one was really challenging to get right was because the fetch API does not have any way to block until the close of the connection happens. And in Easy Racer, this becomes very evident with some of the tests that you, if you haven't actually closed some connections, things get wonky in Easy Racer, and so it highlights that necessity to be able to wait until the connection is actually closed to move on. So I've beat my head against this thing like for a couple years now, the JavaScript implementation, and could never quite get it right. And so this was just a couple weeks ago. I was like, I'm going to just throw this thing at Claude and see if it can figure it out. And of course I told it like all the problems that I was having, and I told it like, here's the scenarios. And then I said, AI, just build this for me. And it crushed it. It like just like something I'd struggled with for years, and it just comes up with the solution to it. And so I now the JavaScript stuff is great. It's not based on fetch. It can't be. It uses some lower level HTTP library in Node, which does allow you to block the execution until the connection closes. And but yeah, amazing that I was able to just like assign a task to AI that it just did a great job with. And a pretty complex thing, but.
Yeah, and Claude, justifiably, I think, has the reputation for being the best, of the coding models at this point. And I'm not surprised to hear that. The other observation I would make, though, of course, me being me, is, well, promise is not even a monad, let alone a monad error. And there's a literally famous thread on GitHub about where Brian McKenna says, if you could just, it was laid in the promise proposal. Brian McKenna hops on the thread and says, could you please make these changes to promise? And
could you please make this promise at least reasonable in some way? And I think the response was, no, we are not going
to. And the response was, we are not in some typed fantasy land. And that led to this informal spec called Fantasyland, of which there are now several implementations in JavaScript and TypeScript and all this kind of stuff. So
and now we have just a very makes me sad promise in the world of JavaScript.
Well, and that sort of brings me back to this business of where we are with LLMs and the infrastructure around them. They're so tightly coupled because I have to say, quite frankly, they come from a culture where specifying logic before you provide implementation is not a thing. And not only is it not a thing, it's the community, the culture is actively hostile to it. And so, here we are, and I'm starting to make my peace with it, but most of that peace comes from just saying, okay, I'm committing to Llama CPP. I'm not going to use the LM Studio server. I'm picking the 3 or 4 models that I have tested and that seem to work well with Llama server, with this set of parameters, with this chat template, with this templating engine. Even, I even noticed that Qwen 3 shifted when they used to have, Qwen 3 used to have their own chat template format. And if you watch the model load in Llama server, it'll tell you what it is. And then I used the Qwen 3 Next, one of the Qwen 3 Next models, and I noticed that they changed their chat engine to Hermes Pro 2. And I think they got so much negative feedback about, hey, Qwen 3, you consistently don't work with these engines. And I think the Qwen 3 team at Alibaba finally said, yeah, you know what, we're going to give up our own template engine, and we're going to use one that seems to work seems to work better for people.
But yeah, I think back to your point, it seems like the people that are building these foundations are maybe not interested or not don't focus on the same kinds of things that I focus on, which is specifying interfaces so that you can I don't know, there's probably a
Right.
bunch of, they're more focused, I'm sure, on raw performance and things that I'm not always interested in. And
Well, and the culture is based on prototyping, right? And that's not necessarily a bad thing. And again, I don't want to make it sound like a moral judgment, which is something that I think those of us who are into functional programming and type systems and all that kind of stuff are frequently perceived as doing. It's not a moral judgment. It's an efficacious. How can you rapidly get to results that you can trust? And there, different people have different opinions about how to go about that. And I've kind of started to make more of my peace with that than I did certainly, back in 2012 and 2014 when Amanda and I were strangely talking about these things.
Yeah.
So lessons learned maybe, but I do find myself, bumping into it very, again, having NVTop lie to me until Tuesday of this week, so it's like there's moving fast and breaking things, and then there's show-stopping, catastrophic, completely untrustworthy, shouldn't be let anywhere near a production code base.
Yeah.
There's a lot of error between those poles, right?
Yeah.
How we even get to someplace, in that middle, I think is the question before us right now. For those of us who are using local models, again, I think the frontier models, with however many trillions of parameters and all that kind of stuff, there are other questions about them, right? And I want to shift. I want to shift to that because we talked about green computing a little bit last time, and I sort of closed on the note of, we've got to do something about the heat dissipation problem in computing. And now it's all over, right? People are up in arms about the amount of energy that these data centers are taking and all that sort of stuff. So I want to. Wow. Okay. Yeah. Let me rapidly close with this. Low power computing is becoming more of a popular concern.
Yeah.
And
this is like Rust, and we've seen the report that ranked the different languages on their
energy consumption.
And so it is becoming more in the zeitgeist that we should care about efficiency. And then with LLM, certainly the conversation is becoming much more relevant.
Yeah, it expands, right? Yeah. The conversation expands. So I have a friend here in town, in Asheville, which is sort of a minor miracle in and of itself, who is heavily engaged on developing essentially a systems programming language derived directly from F Sharp.
Huh.
Nice. Called the Fidelity Framework. His name is Houston Haynes.
Huh.
Really interesting guy, brilliant guy, funny guy. Used to work for Moog back in the day.
Huh.
So he's been immersed in, circuitry in the hardware, and from there up, for decades, and has really focused on different computing models. I said earlier that we've lied to ourselves now for many years that the Intel instruction set, we've lied that these processors have a von Neumann architecture. Right? That's been a lie for decades, for many, many decades at this point. Intel was complaining about it at Google engineering open houses, 20, 25 years ago. They can't keep doing this. They can't keep pretending that they have a von Neumann architecture, that we're going to have to learn how to actually write code for the actual architecture of the processor underneath, which is this crazy, speculative execution and data flow and yuck. Well, now that's becoming much more surface. If you look at manufacturers like Next Silicon and Efficient Computer, which are a couple of chip outfits that I know Houston is talking to and has talked to, they're actually explicitly putting forth data flow processors. Now, it so happens that they know they have to provide a C++ compiler.
Yeah.
They have to run Python, on top of these chips, which means talking to C++, which, okay. So they're very explicit about the fact that to have a C++ compiler, once again, is pretending that you have a von Neumann architecture. It's just that now the pretense is farther outside the core of the chip. They're much more explicit about the fact that the fundamental architecture of the chip is data flow. There's a data flow architecture. Hey, data flow architecture. Gosh, last time we talked about the Blueprints visual programming system in the Unreal Engine.
Yeah.
So we talked about green computing. We talked about data flow programming, visual data flow programming 4.5 years ago. Now, let me strongly encourage you to have my friend Houston Haynes on to talk about the Fidelity Framework and Next Silicon and data flow.
Is the idea here that if we designed our chips in a way that we could then have a data flow, more functional language that could align to that chip design, that chip architecture, then we could get to much higher levels of compute efficiency without sacrificing the programming model? Like I don't want to do C++ or C, and
Right.
and to be able to be efficient. So is this like the have your cake and eat it too kind of vision of efficiency where we don't have to make the trade-offs?
Yeah, to a greater extent. Yeah. Because data flow gets you closer to the ideal that we discussed last time of reversible computing. Well, you don't get to reversible computing, but what you do with data flow is you avoid that heat dissipation from flipping memory bits, right? So data is flowing all the way through the circuit. You're not actually flipping bits and then sort of losing track of that information. And again, that thanks to quantum mechanics, right? We know that information is never lost, whether you like it or not. So the information is lost in conventional hardware to heat dissipation from flipping bits. Thank you, Landauer. That's the Landauer limit that we talked about last time. So with the data flow architecture on the chip, you're doing less of that, not zero of that, I'm sure, but less of that because the data is continuing to flow from this gate to this gate to that gate to that, And so you're not so much flipping bits as you are transforming the data. And even from an information theoretic perspective, you're better off because you have information preservation through that flow. Through the chip.
Yeah.
And that absolutely lends itself to a functional approach.
Yeah.
It absolutely does.
Yeah.
So that one, I'm going to say, we talked about this 4.5 years ago. I do encourage you to re-listen to that and have that little moment of, yeah, boy, we really got pretty close. We got pretty close with a couple of these.
And so now, like what we talked about then, we're starting to see the start of like this having the potential, like the chips are now here, the maybe the languages that work on those chips are coming along. We're still at the beginning, but at least we can see movement happening in this direction.
Yeah. I don't remember where Next Silicon is. Efficient Computer has a prototype board that they're making available to some people. And, when they hand this thing to you today, it's like, yes, you can run PyTorch on this and you can run, your C++ linear algebra libraries on this. Here's our compiler. The efficient computer people in particular have a great set of white papers on their architecture and the decisions that they made in implementing their C++ compiler. They're very upfront about the fact that their C++ compiler literally takes the control flow graph and turns it into a data flow graph. It has to. That's the architecture of their chip. But it is an artifice, right? It is a lie. It is a hack. So you're expressing things in conventional control flow terms that the chip literally doesn't support.
Yeah.
So it has to convert it, and then you lose some of the benefits, of course. You lose something in the translation, literally.
Yeah.
And so what's the opportunity? Well, the opportunity is to talk to the chip more natively.
Mm-hmm.
Right?
Yeah.
And hey, it turns out that those of us who have been preaching functional programming for 30 years are finally coming to our
Why
deserved conclusion.
why did we get to the point where we architected CPUs as control flow instead of data flow?
Well, I think because it was the obvious when you start from the logic gate and build up.
Okay. Yeah.
And you start from early memory architectures and build up.
Yeah.
I mean, okay, let's go back to magnetic cores, right? Literally these banks of, these frames with wires intersecting with, little rings around them at the intersections, right? Those old memory cores, those were on or off. Those were ones and zeros. And you either had a current running through, well, I mean, Claude Shannon, right? Okay. AT&T Bell Labs with the actual telephone switching relays, right? Okay, relay. The contact is either open or closed, right? Couldn't possibly be more stateful.
Yeah.
Right? And Shannon's actual brilliant insight was to look at this bank of these relays with the lever electromagnetic thing going on or off, on or off, on or off. And he looks at him then and goes, gosh, wouldn't it be great if we could express logic in those terms? How would we go about that?
Yeah.
And somehow he became aware, and I have no idea how, but he became aware of this really obscure 19th century Irish mathematics professor who had taken the idea of logic, thousands of years old, right? And said, how can we express this in an algebra?
Huh.
And so it's like, and nobody paid any attention at the time, right? And not for 100 years later until Claude Shannon figures it out. So he's reading George Boole, right?
Yeah.
and realizes that he can implement this algebra with these relays.
Yeah.
On and off, on
and
and
that's
off,
like
on and off.
like building up from those on-offs to Boolean logic, and then from Boolean logic all the way up to control flow, and
right.
And so that's how we got to where we are, and now it's time to rethink things instead of building up from logic gates, but building up or building down from data flow.
Yeah, I would say you don't even have to change the algebra, right? I mean, Boolean algebra is a great abstraction.
Yeah.
Kind of like SQL is a great abstraction. It's maybe that's overstated a bit because it's not a
yeah, maybe argue with you on that one, but
it's not a great implementation of the relational algebra.
Yeah.
Right? But it is pervasive, and you can get there from here. Like if you read C.J. Date, SQL and Relational Theory, you can get there from here.
I guess my issues with SQL are the syntax, not the actual like algebra of relational queries or something. But
but SQL itself is also not compositional, and I think that's where you want something like a data log or something like that.
Yeah.
There are better query languages, much better query languages. Anyway, the point is that we have this massive wealth. We have this massive wealth of history that people like Claude Shannon, people like George Boole, and on into the current time. John McCarthy, of course, Sussman and Steele with Scheme. Actually, that's another funny. We talked about evaluation order before. Scheme does not actually specify, the Scheme standard does not actually specify the order of evaluation of function arguments, and it matters. So you can have, because Scheme has effects, it's the Algol 60 problem. So you can have Scheme code that has effects, and if you use a function that has an effect as an argument to another function, what order those effects happen in can change depending upon what Scheme implementation you're running.
Huh. Interesting.
Yeah. So it's a commonplace to say the Scheme is eagerly evaluated. That's true as far as it goes, but it doesn't specify the order of evaluation of function arguments. So
yeah. That's a problem.
All bets are off.
Yeah, there's no algebra there.
Maybe not eager enough.
Yeah, not eager enough or not lazy enough. And Dr. Friedman, Dan Friedman, who was also at IU when I was there, had written a paper a couple years earlier entitled "The Cons Should Not Evaluate Its Arguments," and he made an impassioned plea for introducing laziness in that very specific way, in that very specific place, in scheme, and nobody took him up on it. So anyway,
well, we have a lot to for me to follow up on, and I think our show notes are going to be pretty extensive on this one. So,
well, let me narrow the focus a bit for you, if at all possible. So, first of all, do please look into verse. I think that's going to be, it's one of those things that's either going to redefine how we do programming, or it's going to disappear from the face of the earth. I don't think there's room for much middle ground there. And given that tens of thousands of people are already using a version of it in the Unreal Editor for Fortnite, I'm betting on the former rather than the latter. Also, just given the provenance, right, with Simon Peyton-Jones and team, building.
Seems like they've assembled some
rock
rock stars.
Interesting.
Yeah,
it's going to be interesting. Whatever happens, it's going to be interesting. And then the other thing is, please invite my friend Houston Haynes on to talk about the Fidelity Framework, F#, why it makes a fantastic systems programming language, low power computing, the tragedy of the tragedy of this pretense that we're still using a von Neumann architecture at this point.
Love that. Thanks for this whole conversation, and definitely look forward to following up on those two things. And I always learned so much from you and our interactions on social media, and always great to have you on to continue the learning,
catch up.
and be able to ask questions too, which you always have such insightful answers. So
thank you. Appreciate that. Yeah. And on the book, I know you guys are hard at work on it. Don't hesitate to email me or whatever, if there's anything I can contribute.
Okay.
We should run our introduction by Paul once we get that into a good form, because I think we really, with this new edition, want to really nail the reason for effects, and it's been a really hard challenge to do that. I mean, we've spent 5-6 years on trying to kind of convey the value of effects, and we really want to get it right, and so would love your feedback on that.
Well, I'll do what I can. What I would say is there's something to be said already for the fact that Effect TS is as popular as it is in the TypeScript community. So there's some sweet spot that it's hitting that Zio didn't hit, Cat's Effect didn't hit, Haskell certainly didn't hit. So what is that?
I think
what's
the sweet spot it's hitting is that if you are doing anything complex in JavaScript or TypeScript without effect, you're in a world of hurt. Like if you want to produce like good software in the world of JavaScript or TypeScript without effect, you're gonna have a really hard time.
It is, but I wonder. I do wonder what. My suspicion is that people are using a subset of it.
Yeah,
and I do wonder what subset they're actually using.
Right.
Yeah. I think there are some that just do the error handling.
Well, that's just the easy
because
path.
they got tired of the exception.
But you could do
nonsense.
that without an effect system.
You could, and somebody actually that's pretty involved with TypeScript effect just created a library for TypeScript that is just the error handling.
Oh yeah, there's several in Python.
Why go all the way to effects if you're just using it for error handling?
Yeah, I used to object to that. I used to object to, it's like, okay, you're imposing a ceiling on your understanding. You're taking one little fragment of what this is about and turning that into some new religion or something. And I used to object to that much more strongly than I do these days. These days, I'm much more inclined to say, if that's the springboard that gets you there, great.
I don't know that it does. That's what.
It may or it may. Yeah, right.
I think
it
may be a place where you get eddied.
Yeah,
and you just go, this is good enough. This solves something that's been bugging me, and the rest of it's too much work to figure out.
Right,
so So we're
it can be a local maximum. Yeah, can be. And if your book can help people get out of that local maximum, so much the better.
Yeah,
we're working on.
Yep.
All right.
He says wearily.
Yeah. Okay.
Well, thank you so much,
Thanks,
Paul.
guys.
All right.
Yeah, absolutely. Talk
Bye.
to you soon. Bye-bye.